In this video, I'd like to look at a one-bit comparator and show that, that we know the inputs, whether A is equal to B, whether A is greater than B, and then use that one-bit comparator to make a 4-bit comparator. So here is my one-bit comparator. So I have two inputs, A and B, which can be high or low, and two outputs, equal or A greater than B, which can also be high or low. So let's start off with low, low. So A and B are both low. And I have an excluded NOR is the equality, and A and not B is the A greater than B result. And I see here that if A and B are both low, that we get that they are equal, yes, true, and that is A greater than B, the answer is false. So let's do A high and B low. Now they are not equal, and it's true that A being high is greater than B, so that makes sense as an output. Let's do the opposite, A low and B high. Then they are not equal. A is low and B is high, so they are not equal. And A being low is not greater than B, so they're both false. And then now if they are both high, A is high and B high, then we're back to A and B are equal, but A is not greater than B. So we have a one-bit comparator here. Now I'm going to drag across a box that cuts the A and B inputs and the equal and A greater than B outputs. And I'm going to come back and do that again in a minute. Let me show you what I have over here. I have some pre-built adder circuit. So here I have these full adders. I'm going to convert this adder circuit into my 4-bit comparator. So I'm going to do a save as with this and do call it a 4-bit comparator. And so I want the display, I want A and B, I want the switches so I can input a 4-bit number. I want the display to see the two numbers, but I'm not interested anymore in the adders. No, I just deleted too much. Let's get rid of the adders and this other display. So I have right now this 0 is the ones place of A, and this A is the ones place of the B number. Okay. And let me just, if I can, drag these B's to separate them a bit from the A's. Okay. And I'm going to go back to my 1-bit and I'm going to drag across so that I'm cutting the a line connecting to the A input and a line connecting to the B input. And also I'm cutting a line that goes to the equality output and the A greater than B output. And then I'm going to come over to the other circuit and I'm going to paste special as a subcircuit. And I'm going to call that just to compare the 1-bit comparator. And that's no good. I have no lines, no input or output. So I'm going to cut that. I'm going to try again, come back here. And when I drag, I need to make sure I'm cutting the line A and B. Let's try that again. Let's do a copy. And let's over here do a paste special. I don't think I did the copy before. Here's my paste special. Let's see if I can call it compare. That may be taken now. No, it's okay. Okay, so here it gave me this subcircuit. Let me open the sheet and we see this IO, what they're calling IO3 here. I want to be call it A. This IO4 I'd like to call B. This IO1 I'd like to call A equaling B. And this IO2 I'd like to call A greater than B. Okay. And I would like to again edit the symbol. I don't know why I seem to have to do that twice, but I seem to have to do that twice. I'm going to drag B down. I'm going to drag A around. I'm going to squeeze it down a little bit. Okay, I'm happy with that, I think. And save yes. So now I have a comparator. This is a 1-bit comparator. I want 4 of those. And then the way I'm used to doing this is I'm used to comparing the 8th place on the top. I'm going to compare the 8th place of A to the 8th place of B. I'm going to compare the 4's place. That is here. That's the 4's place of A to the 4's, oops, sorry, the 4's place of B. Changing my colors, but I'll live with it. This should be the 2's place of A to the 2's place of B, which is there, and the 1's place of A should be compared to the 1's place of the B number. Okay, and I'm going to try to change these colors back, make my A's purple, just to organize myself a little bit. And make my B's green. I should be comparing, and then now let me place a label on this guy, or text. And this was my 8th place. And then I'm going to also place a label down at the bottom, or text, to say that this is the 1's place. I'm going to make myself just extend these lines, drag in, drag out, and double click. And I'm going to make equality, which is the upper one, blue. For a very colorful circuit here. Okay. And we showed that this box was a 1-bit comparator. And now I want to turn it into a 4-bit comparator. And I have to say what kind of 4-bit number I have. And I am going to have an unsigned number. So I'm not going to, so these numbers are purely positive. I'm not worried about signed bits. I'm not doing 2's complement. I'm doing two's complement, I'd have to treat the most significant bit or the signed bit differently. But I'm going to assume this is unsigned 4-bit number comparator. Equality is simple. It's a 4 input and. Let's just do that for now. If the 8's place have to be the same and the put this vertically. So for equality, the 8's place should be equal and the 4's place should be equal. And the 2's place should be equal. And the 1's place should be equal. And let me grab myself a probe. Go with orange. Now I was doing blue for equality, so let me stick with the blue. Now I have too many. Okay. Put this one vertically, connect it. And let's play the game. Okay, let's turn this on. This is supposed to be right now. I have all lows for both the number A and the number B. And let me just flip these switches so then I can get my, I'm going to flip 0 and go back and flip A and go back. So I'm displaying. So right now I'm comparing the number 0 to the number 0 and they are equal. I'm now looking at a 2 for A and 2 is not equal to B. The A number 2 is not equal to the 0, which is number B is 4-bit number B is 0 now, but if they're 2 and 2, they are equal. If it's 6 and 2 are not equal, but 6 and 6 are equal. E is not equal to 6, but E is equal to E. So I think the equality seems to be, I didn't try all possible cases, but it seems to be working. And now there are 4 possibilities. So I want logic, I want this digital, there are 4 scenarios, so I want a 4 input OR ultimately. 2 of them. I'm going to bring this probe down eventually. Rotate this guy. Right, so what are the scenarios for a 4-bit A being bigger than a 4-bit B? And I have, again, the 8's place at the top. So if the 8's place of A is bigger, which is the red, if the 8's place of A is bigger than the 8's place of B, then we're done. Then A is bigger than B. The next scenario is if the 8's place are equal and the 4's place is greater. So that's I need a 2 input. And I want a 2 input and I'm going to rotate that. Put more down here. So the first scenario is the 8's place of A is bigger, but if the 8's place of B are equal and the 4's place is bigger, that's my next scenario. Then my next scenario after that is 4 for that one. My next scenario is if the 8's places are equal and the 4's places are equal, but the 2's place is bigger. That's my third scenario. for the 4-bit word A being bigger than the 4-bit word B. And then my last scenario is for the 8th place to be equal, the 4th place to be equal, the 2's place to be equal, but the 1's place to be bigger. So it should always be red, blue, red, blue, blue, red, blue, 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 red. That is my last scenario for the 4-bit word A being bigger than the 4-bit word B. Okay. Let's make it a little bit bigger. Scroll up, scroll over. Turn it on. Okay, it's on. Right now I have E and E, and so E is not greater. This down here is the greater than, so E is not greater than E. Let's go all the way back to low, low, low. And B, C, D. So right now I have 0 and 0. They are equal. If any of the bits of A are higher than 0, so if any of these bits, then that came higher. If A was a 1, I need 1, it's not greater, but if it's 2, it is greater. And etc. we'll say. So right now I have neither. I have my A input is 0, my B input is 1, and it's A is not equal to B, and A is not greater than B. So I have 2 falses at this stage. So that's a 4-bit comparator. I started with a 1-bit comparator where I could go easily through the full truth table. There were 4 possible inputs. I made that a subcircuit and brought it into this circuit, and I had 4 inputs for A, 4 inputs for B. I had to decide what I was comparing. I'm comparing 2 4-bit unsigned numbers, so I'm not worried about them being signed numbers, so that makes it simpler. And then I just used my 1-bit. I compared the 8's place, the 4's place, the 2's place, and the 1's place. They all had to be equal for it to be equal. And then I had my different scenarios for A being bigger than B. If it's bigger than the 8's place, we're done. If it's equal in the 8's place, but bigger in the 4's place. If it's equal 8 equal 4, but bigger 2. If it's equal 8 equal 4 equal 2, the bigger 1. Those are all the scenarios for A being bigger than B. Okay, that's what I wanted to show you in this example. Thank you for your attention.